Right now, something unusual is happening at the two most remote places on Earth. At the top of the planet, Arctic sea ice has just reached another historic low. And thousands of miles away, at the bottom of the world, Antarctica is telling a very different story. One that is almost impossible to understand if you only look at a single year of data. The strange part is not that both poles are changing. It is that they are changing in completely different ways, while both remain connected to the same rapidly warming planet. So what exactly happened? And why are scientists paying such close attention to both ends of Earth right now? I'm Arif Hassan, and this is AH History. Let's begin at the North Pole. The HEART's warning. Every year, Arctic sea ice expands during the dark winter months before reaching its maximum sometime around March. Then, as sunlight returns, the ice begins its seasonal retreat. For decades, scientists have tracked this cycle using satellites. And in 2026, the measurement produced another extraordinary result. On March 15th, Arctic sea ice reached an estimated maximum extent of 14.29 million square kilometers. That was statistically tied with 2025 for the lowest winter maximum in the satellite record, which stretches back to 1979. Think about what that means. This wasn't the summer minimum. This was the point in the year when Arctic sea ice should have been at its greatest extent. Yet the winter maximum was sitting at the bottom of nearly 5 decades of satellite observations. And that is why the number matters. One unusual year can happen. But when consecutive years occupy the lowest part of a long-term record, scientists start asking a much bigger question. Has the Arctic system itself entered a different state? There is another reason this matters. Arctic sea ice isn't simply a giant frozen landscape. It acts as part of Earth's climate system. Ice and snow reflect a large amount of incoming sunlight back towards space. Open ocean is much darker and absorbs more solar energy. So when sea ice disappears, more dark water is exposed. That water absorbs additional energy, and that can make it harder for ice to return later. This is known as the ice albedo feedback. It doesn't mean every square kilometer of missing ice automatically causes the next square kilometer to disappear. Weather, ocean currents, winds, and seasonal conditions all matter. But it does mean the Arctic contains a feedback mechanism capable of amplifying warming. And that is one reason researchers aren't treating the latest record as an isolated curiosity. Something different happened, Such. Now travel nearly 20,000 kilometers in the opposite direction. Antarctica. This is where the story becomes much more complicated. Unlike the Arctic, Antarctica is a continent surrounded by ocean. The Arctic is essentially an ocean surrounded by land. That difference completely changes how sea ice behaves. And for years, Antarctic sea ice did not follow the same pattern as the Arctic. There were periods when Antarctic sea ice remained relatively stable, and some years even showed increases. Then came a dramatic shift. Antarctic sea ice experienced exceptionally low levels in recent years, including record low conditions in 2023. But here is where the latest data becomes important. In 2026, Antarctica did not continue breaking records. According to the National Snow and Ice Data Center, Antarctic sea ice likely reached its annual minimum on February 26th at approximately 2.58 million square kilometers. That ranks 16th lowest in the 48-year satellite record. It was still about 260,000 square kilometers below the 1981 to 2010 average, but it was dramatically higher than the record low set in 2023. At first glance, that sounds like good news. And in one very important sense, it is. The Antarctic system showed that extremely low sea ice conditions can be followed by a substantial recovery. Strong southerly winds helped push ice outward in the Weddell Sea during January and February, slowing the overall decline and helping bring the 2026 minimum much closer to average. But this is where we need to be careful. A recovery in Antarctic sea ice does not mean the entire Antarctic ice system has suddenly returned to normal, because sea ice and land ice are not the same thing. And that distinction is absolutely critical. The HE ice that rises SCA level. Floating sea ice is already floating in the ocean. When it melts, its direct contribution to sea level rise is relatively small. But Antarctica also contains an enormous amount of ice sitting on land. That is a completely different story. When land-based glaciers and ice sheets lose mass and that ice eventually reaches the ocean, it adds water to the world's seas. So scientists don't simply ask, is Antarctic sea ice increasing or decreasing? They also ask, what is happening to the ice sitting on the continent? And this is where Antarctica becomes one of the most important places on Earth to monitor. The continent is not responding uniformly. Different regions can behave very differently at the same time because Antarctica's atmosphere, ocean currents, winds, and underlying geology interact in extremely complicated ways. That is why one satellite image can sometimes look reassuring while another part of the continent is showing serious changes. And it is also why scientists are extremely cautious about using 1 year's sea ice number as proof that the entire Antarctic system is either recovering or collapsing. TWO poles. TWO different stories. Now step back and look at both poles together. The Arctic just recorded another statistically tied record low winter maximum. Antarctica, meanwhile, experienced a much less extreme 2026 minimum after several years of exceptionally low sea ice. So the story isn't, both poles are doing exactly the same thing. They aren't. The real story is much more interesting. Earth's polar regions are responding to changing conditions through different physical mechanisms. In the Arctic, we're seeing a long-term decline in sea ice, with 2026 continuing that record low pattern. In Antarctica, the year-to-year variability is much larger, and recent conditions have demonstrated just how dramatically the system can swing. NASA and NSIDC emphasize that Arctic sea ice has reached statistically tied record low winter maxima in 2025 and 2026. And NSIDC's Antarctic data shows just how different the southern story can be. 2026 was far from the record low of 2023, despite remaining below the long-term average. That contrast is scientifically important, because it reminds us that climate change doesn't mean every location changes in a perfectly straight line. Nature rarely behaves that neatly. WHYSC scientists care abrupt Thwaites nyambar. So why does a winter record in the Arctic matter to people who may live thousands of kilometers away? Because sea ice interacts with the atmosphere and ocean. The Arctic is not an isolated freezer floating above the world. It is part of a connected climate system. When ice cover changes, the exchange of heat and moisture between the ocean and atmosphere can change as well. And the loss of reflective ice also alters how much sunlight is absorbed by the surface. That doesn't mean scientists can look at one low sea ice year and predict exactly what weather your city will experience next winter. They can't. Weather is much more complicated than that. But the long-term transformation of the Arctic is an important signal that the physical environment of the planet is changing. And the satellite record makes that signal increasingly difficult to ignore. VHE, part, most, PUPLE, MESS. Here's the biggest misconception about polar climate stories. People often imagine that scientists are watching a giant block of ice simply melt away year after year at a constant speed. That's not what happens. Polar systems fluctuate, winds change, ocean currents shift, storms redistribute ice, temperatures vary. Some years are dramatically different from others. That variability is exactly what makes Antarctica so difficult to interpret. In 2026, Antarctic sea ice moved much closer to its historical average after several years of extremely low conditions. NSIDC scientists specifically noted that the large year-to-year variability in Antarctic sea ice makes such changes possible. But variability doesn't erase the longer-term record. The satellite era now gives scientists nearly 5 decades of consistent observations. And those observations allow researchers to distinguish between a temporary fluctuation and a persistent change. That distinction is incredibly important because a single recovery doesn't automatically reverse a long-term trend, and a single record doesn't automatically prove that the entire system has crossed a permanent tipping point. The science lies in watching what happens next. What happens next? For the Arctic, scientists will be watching the next seasonal cycle closely. Will sea ice recover significantly during the coming months? How low will the summer minimum eventually go? And will the Arctic continue producing winter maxima near the bottom of the satellite record? For Antarctica, the questions are different. Will the relatively strong 2026 recovery continue? Or will the system once again experience another period of unusually low sea ice? And perhaps most importantly, what happens to the land-based ice beneath and around the continent? Those questions cannot be answered by a single photograph. They require satellites, ocean measurements, atmospheric observations, ice cores, computer models, and years of continuous monitoring. And that is exactly what scientists are doing. The Bejur picture. So, what just happened at both ends of the planet? At the Arctic, 2026 produced another record low winter maximum, statistically tied with 2025 at about 14.29 million square kilometers. At Antarctica, the story was almost the opposite. The 2026 sea ice minimum recovered substantially from the extraordinary lows of recent years, reaching approximately 2.58 million square kilometers and ranking 16th lowest in the satellite record. And that may be the most important lesson of all. The planet's climate system isn't moving like a simple machine. It is a collection of interconnected systems responding differently to changing conditions. One pole can produce a record while the other experiences recovery. One region can lose ice while another temporarily gains it, and both can be true at the same time. That doesn't make the changes less important. It makes them more complicated, and complexity is exactly why scientists keep watching. Because the real question isn't whether one year looks frightening or reassuring. The real question is, what does the next decade look like? The satellites will keep watching, the instruments will keep measuring, and the ice will keep giving us evidence. The question is whether we're paying close enough attention to understand what that evidence is telling us. I'm Arif Hassan, and this is History. If you want more documentaries exploring the discoveries, mysteries, and changes shaping our planet, subscribe to History. And tell me in the comments, which story surprised you more? The Arctic reaching another record low winter maximum, or Antarctica's unexpected recovery in 2026? Because at both ends of the planet, one thing has become impossible to ignore. The poles are changing, and they are not changing in the same way.